Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I am really excited to introduce our guest for today, John Rood. He is the CEO of Momentus Space. Welcome to the show, John.
Great to be with you, Lisa. Thanks for having me on.
Absolutely. Thank you for making time to be here today. Maybe we can start by having you give just a little bit of background on yourself and Momentus Space.
Sure. I've been at Momentus Space for about 3.5 years. I'm the CEO there. And Momentus Space produces small satellites and orbital service vehicles to deliver other small satellites to custom orbits or just hosted payloads. And we also make satellite components such as avionics and a solar array that we're developing that rolls out for low cost and for relocatability. But I have a career both in government and in industry. I spent time as a senior vice president for international business at Lockheed Martin and also at Raytheon, where I was the vice president for business development for the US market. And in addition, I've had roles in the government like Undersecretary of Defense for Policy. I was an Undersecretary of State for Arms Control and International Security, and began my career as an intelligence analyst and spent some time at the White House along the way in Capitol Hill. So I've sort of had a varied career.
Wow, amazing. That is an amazing background. So maybe we can talk a little bit about how Momentus is actually supporting the future of space operations.
I think there's a couple of mega trends that are influencing the space industry. Number one, if we were on this call, say 20 years ago or something like that, we would be talking about how difficult it is to get a ride to space and how the cost of launch was very prohibitive. So launch was a scarcity and it was a barrier to entry, quite frankly, due to the cost. But the cost of launch has come down by over 95% in the last 20 years, according to McKinsey, and availability is high. Certainly not something you can book for next month or something of that nature, but booking a launch to fly in a year or a little less than a year is very doable today. Secondly, the revolution in microelectronics and a range of other technologies for communications have shrunk the size of satellites to be a small fraction of what they used to be in order to perform similar missions. So you have these two mega trends going on at the same time, that the size of the objects and the capability that you want to place in space are much less costly and weigh a lot less. And the cost for launch has come down dramatically. So it's made it possible to do many things in space that previously were done just on Earth or with airborne applications, and it opened up a range of new possibilities. And so smaller companies like ourselves are trying to fill that void, surging in to produce smaller satellites that can be readily reconfigured because they're modular and not tailor made for a single purpose. And then, secondly, that you can support a wide range of applications in different orbits at a very low price point. And then add on top of that the ability to service very small payloads to deliver them to custom orbits. For example, some of the customers we've supported are Internet of Things connectivity firms. They want to have several hundred or several thousand very small satellites deployed around the globe. And we can sort of be like the UPS of space and deliver parcels to many locations on one truck, or host payloads that where people don't need a satellite. They just want to put their instrument or their communication system or their other activity, camera or something of that nature on board, and we can handle that. So the barrier to entry gets even lower, and the range of applications that can be supported and compete on a price basis with those on Earth becomes really attractive. And I think that's why you're seeing a growth in the size of the space economy and the type of applications that are done.
Yeah, absolutely. So at the opening, you talked a little bit about the in-space transportation services that Momentus provides. Can you talk a little bit more about that and why that is so important? Because can't I just get to where I'm going, via a SpaceX rocket, for example? What is the missing gap that Momentus is filling there?
There's a couple of them. One, depending on if you have several satellites, and there are many people that are pursuing constellations of smaller sizes, think 8, 16, 60 satellites around the globe. If you go up on the launch vehicle and are simply dropped off, if you will, dispensed at a certain altitude, first of all, you don't get to choose what that altitude is or where in what inclination you're going to. Um, the larger customers on a SpaceX launch or another rideshare launch would determine that location that the launch vehicle is going to. And as a ride-along passenger, you're obligated to go where they're going. But if you want to be redistributed, or you want to be in a specific location, that's where you need a service like what Momentus provides. Particularly if you don't have onboard propulsion on your satellite, or the time required to take you can be quite long using onboard propulsion, and you're really shortening the length of the life of the satellite. So we've delivered 17 customer satellites in our company's history, and that's part of the reasoning for those. For example, Internet of Things connectivity firms or companies with small constellations for Earth observation, they need to be in specific locations, or we delivered a couple satellites for NASA to a specific location. Those are the kinds of applications for the same reason that I like, and this is going to get more pronounced with something like Starship. Starship will be this enormous launch vehicle, and that's wonderful for the potential reduction in launch costs. But I think it'll be a lot like these very large container ships on Earth that go across the ocean and carry thousands of shipping containers. But then once they arrive at port, there are trucks that carry those to many, many locations. And that's a lot of the role that we play with respect to transportation. The other reason to use us is if you're a small provider and you're just getting started, it's a little bit like using a freight forwarder service on Earth. For some people that have moved, can't afford the whole truck, maybe you don't have enough stuff to fill up a whole 40-foot shipping container to move your goods to, or you're moving overseas. But there are companies that will handle all of that for you and consolidate the cargo, pack it neatly, handle all the regulations for travel and transport. And there's a very similar thing here in the space industry that we provide. There's a regulatory burden getting the right licenses from the FCC, the FAA, NOAA, and others, and then making sure that your payload is properly integrated, safe, and will arrive at the destination in the correct orientation and correct condition. And so that's the other service that we provide, along with essentially our truck in space that can deliver things. Now,
That's
as you get further along and you talk about deorbit in a mission, the FCC has a requirement now for deorbit within 5 years of end of useful life. And that's an emerging market where small space trucks or tugs like ourselves can play a role in deorbiting and repositioning satellites that have failed, or that maybe there's a missing node in a network where you need to reposition a satellite to fill that, or refueling, repair, things of that nature.
wow. So endless applications. Can you talk a little bit about the hosted payload solutions that Momentus provides? What types and sizes of payloads are you supporting?
For a hosted payload, we support a broad range of them for things like Earth observation, for testing communications equipment. Many times, providers of new technologies or new satellites want to have certain components flight qualified to spend time in space, to prove to themselves or to investors or customers that the product, their aviation component, their flight computer, communications equipment, camera, whatever the mission of the system is, that it has performed to specification in the intended orbit. And that's one of the reasons a hosted payload can play that role. And we provide that service. In other cases, the provider of it doesn't want to build their own satellite. They're focused on their instrument. And we can support a very broad range of sizes and masses. Our vehicle, called Vigoride, can carry up to 800 kilograms of payload when mounted in the top mount or cake topper configuration. And on side mount, using an Espa Grande ring, we can carry 350 kilograms of payload mass. And then in closed volume, we can do about a meter of enclosed volume for ours, and our deck is 1.5 by 0.9 meters, so we can accommodate fairly large things, particularly if they're deployable. So as an example, we carried one payload for Caltech, and what they wanted to demonstrate was the ability to transmit electricity wirelessly that they collected from solar energy, first in space, from one point to another point in space, and then secondly, from space to Earth, wirelessly to transmit the electricity. So we carried their hosted payload. It deployed to a very large size with booms extending about 6 feet up and a series of deployable structures that went to be several meters across. And then what they did is they unfurled this sort of carpet of collectors for both solar energy and radio frequency transmitters, and successfully collected solar energy in space and transmitted it wirelessly, first in space, and then a small amount to Pasadena, California, to the roof of Caltech, where they collected it. They say, Caltech tells us, that's the first time in history that was done.
Oh, wow. That is amazing.
And there are other hosted payloads that we've done that are simpler, cameras that need to operate and take visuals, things of that nature. But I thought the Caltech mission was really special.
Yeah, that is.
Groundbreaking science.
Absolutely. So I understand that you actually have a space flight coming up in early 2026, and that there may be some payload space on that flight still, maybe?
Yes, we've booked a launch that will go on a SpaceX transporter launch as early as February of 2026, and there is still space available on that. If you're interested, please contact us at Momentus Space, and we have space available both for hosted payloads and deployables. We'll be going to sun synchronous orbit, about 525 to 550 kilometers drop off altitude, but we have the ability to maneuver to substantially large distances from that point. So we'll be able to accommodate a broad range of customers. We have several that are booked, both from government agencies like DARPA, but we also have commercial customers that will be flying with us.
Wow, that's amazing. That is amazing. Can you talk about any, I don't know how much you can talk about this, but can you talk about any of the use cases that you'll be supporting on that space flight?
Sure. The core anchor tenant, if you will, is DARPA, the Defense Advanced Research Projects Agency. And what they will be doing is we will carry a payload for them that will do in-space assembly. And they intend to, in space, robotically assemble a very large structure simulating a very large antenna, with the idea being you take the pieces to space instead of all of the complexity and cost of deployable antennas, deployable structures that are typically the biggest areas where risks and failures occur in space. And so the thought is to really break the cost curve here, to take parts to space that are then assembled into a structure that wouldn't fit within the shroud of a launch vehicle. And so DARPA will do that as part of a program called NOMAD. And this is first of its kind. So they pride themselves on DARPA hard, pushing the envelope of technology, so that this will be an instance of that for the robotic assembly. A second payload we're going to carry will be for the Air Force AFWorks, which is the innovation arm of the Air Force Research Labs. And what it will do is we're providing a multispectral rendezvous and proximity operations sensor suite. So we will have, we've been awarded this program. And what it'll do is we'll have infrared cameras, optical cameras, and two types of LiDAR, or laser imaging detection and ranging systems on board. and we'll deploy a target satellite, and then we'll come within up to 2 meters is the program plan of that, and take observations and show the ability for these different sensor suites to and some autonomous operation of the vehicle for close proximity operations. Um, and then some of the others are commercial customers. Some are just going to be dropped off. Others are going to test their payload in space. So, be kind of a nice mixed use mission, if you will, that'll go on for many months in space after we get to orbit.
Wow, that's really exciting. Those are some exciting initiatives. And can you talk a little bit about the role that in space communications will play in those initiatives?
One of the companies that is really innovative that we are going to be flying for the first time is called Solstar Space. And we're pretty excited about this mission, which will be the first of its kind for Solstar, and is part of a strategic partnership we at Momentus have with Solstar Space. And what that company does is they produce a system. In this case, it's going to be called the Deke. Deke Slayton, very famous astronaut, so this is named after him. But the Deke will allow you to essentially have Wi-Fi connectivity with your payload in space. Um, you can sit at your laptop, go over your internet service provider, whatever company that is, and type on your keyboard and communicate with your payload on demand, 24 hours a day, 7 days a week, same way that you and I are communicating now over the internet. And it's done by this very new. This will again will be the first flight of this Deke technology, and so we're pretty excited to be the ones hosting that. And candidly, we want to use this going forward, and we want this partnership because we think it's something that all of our customers in the future are going to want, or a large percentage of them, anyways. And we intend to use it. And the reason is that today, when you communicate with your satellite, and that's our Vigoride vehicle there in the upper left, looking down at the Earth, we take these pictures with our onboard cameras, and never gets old to me looking at them. But the part that it will allow you to do, though, is instead of today, where communicating with that vehicle, when it flies over certain ground stations or it's in view of a ground station, we'll have essentially burst communication transmissions. We'll save up commands, we'll save up things that we want to, excuse me, upload onto the satellite. But then we also have burst transmissions downward, and those passes are usually 10 minutes or something like that. And it can vary greatly how frequently they are, depending on what service you're using, what company. You might have to wait 8 hours or 10 hours or 12 to communicate, or it might be as short as 90 or 120 minutes. But it definitely is a challenge that we're used to today, and we overcome readily. But the idea that you could have on-demand 24/7 communication with your payload or your satellite is really attractive as an improvement. Particularly, frankly, if you're having an anomaly or you're working through a problem, it can be incredibly frustrating that you're working through that. You're waiting for the data to come back from the satellite, and it slipped out of the pass. We need to wait 6 hours till it's in view again. And if it's something you're concerned about, those are some sweaty palm, nervous moments,
Yeah.
wondering. Um, and with this kind of technology, you wouldn't have that. But even just for convenience or the ability to work in a continuous manner that we take for granted because we're so used to doing that on Earth, that's what this will give you.
That's amazing. That sounds like this is very exciting. So we're looking forward to watching as that space flight gets launched. Can you talk a little bit about Momentus's satellite integration solutions?
Absolutely. We make small satellites. It's the same technology stack that we use to play the role of being an orbital service vehicle, delivering smaller satellites or hosting payloads in orbit. So we use that chassis, if you will, or bus, and we offer it as a small satellite bus, both in LEO as well as in GEO. And so we have bid several programs with the government and have won some contracts like the HALO program with the Space Development Agency, which is intended to do development and testing of new technologies. So, for example, we'll be one of the companies bidding for a offering under that program to provide 2 satellites that will host communication systems to prove the ability to communicate in jammed or denied type of environments. And so we're bidding on that here just in the next couple of months. But also, we offer small satellites to commercial customers for things like precision navigation and timing, communications. We're going to bid again later this year for a missile tracking program that the Space Development Agency has put out for solicitation. So there's a series of different ways that they will do that. In some cases, also for small geo satellites, that's an offering we provide. We've had some customers come to us and ask us to design those. And we're very pleased with how competitive we are, both on the technology, the speed to delivery, and importantly, the cost. Communications is a very price sensitive world for telecom solutions and satellite communications. And so the ability to provide a strong service at a much discounted price is very attractive to customers.
Yeah, no kidding. No kidding. Well, I want to end with one last question, and that is if you were to make one prediction about the future of in-space operations, what would it be?
Well, there are a lot of jokes about the hazards of predicting the future, but I'll go ahead and give it a try. Um, I'd say I think we're going to see in-space transportation and manufacturing become much more prevalent. The technology, as it matures, it makes sense to do assembly in space in the same way that, if you've ever bought furniture from a store like IKEA or somewhere else, that it comes in flat boxes that you then assemble the pieces. And it's done for cost reasons and shipping reasons. And the same thing applies to space technology. And so the ability to do assembly of things in space will really change what we're doing in space to not be limited to the constraints of this relatively small shroud that the
Mhm.
launch vehicle has, number one. And number two, these highly complex systems that articulate and deploy, they drive more cost than the articles themselves, the systems that do that. So number one, I think you're going to see in-space assembly become much more routine. And I think you're also going to see the ability to deorbit items of interest become much more routine because we're going to have to. There's just
Mhm.
too many things going into a crowded, congested area, and the risks of collisions or conjunctions are too high. So
Yeah,
I do think you're going to see both of those begin. And as more things are done routinely in space, it'll create a little bit of an ecosystem where you're going to need support systems for in-space habitation and manufacturing. But I think the in-space assembly and deorbit are where I'm thinking you're going to
yeah.
see the earliest applications and possibly refueling for certain classes of satellites where it really makes sense.
Sure, sure. Okay, well, we'll be watching as all of these things come to pass and as Momentus supports those programs. Can you tell us if somebody was interested in learning more about Momentus Space, what should they do?
Just contact us at momentusspace.com. If our sales team, our management team would be very happy to meet you and talk about those things. So please reach out to us.
Great, great, great. Sounds fantastic. Thank you so much for making time to be here today. We really appreciate it.
You bet. Great to be with you.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.